Here's the solution for homework 10, question 1. This question is collect the definitions and the simple properties of examples of stochastic processes. The first stochastic process, is the Poisson process. The Poisson process is defined by the following properties. The number n(t1, t2) of the points ti in the interval t1, t2 of length t equal to t2 minus t1 is a Poisson random variable with parameter lambda t. The probability of n(t1, t2) equal to k is equal to e to the power of minus lambda t multiple lambda t to the power of k over k factorial. If the intervals t1, t2, and t3, t4 are non-overlapping, then the random variables n(t1, t2) and n(t3, t4) are independent. And at a time moment t, there is no more than one Poisson point. Using the point ti, we form the stochastic process xt equal to n0 t. The first order probability methods, the probability of x t equal to k is equal to e to the power of lambda t multiple lambda t to the power of k over k factorial. The mean is lambda t, and the autocorrelation is rt1, t2 equal to lambda square multiple t1, t2 plus lambda multiple minimal value of t1, t2, and the autocovariance is ct1, t2 is equal to lambda multiple minimal value of t1, t2. The mean of the Poisson process is lambda t, which is a linear function of t, and the Poisson processes also means that if we wait for a bus, for example, the longer time we wait for, the expected number of buses is larger. And the autocorrelation function contains a term minimal value of t1, t2, which comes from the property of independent increments. The second one is Poisson increment process, which is defined as yt is equal to xt plus epsilon minus xt over epsilon, where xt is a Poisson process. The first order probability method is e to the power of lambda epsilon multiple lambda epsilon to the power of n over n factorial. The mean is lambda, and the autocorrelation is lambda square if the absolute value of t1 minus t2 is larger than epsilon, and it's equal to lambda square plus lambda over epsilon minus lambda multiple t1 minus t2 over epsilon square. When ty, the absolute value of t1, t2 is smaller than epsilon, the autocovariance is 0, 1. The absolute value of t1, t2 is larger than epsilon, and is equal to lambda over epsilon minus lambda multiple absolute value of t1 minus t2 over epsilon square. The Poisson increment process is introduced to prepare us to define Poisson impulse process. It is interesting to see that in the expression of autocorrelation, this part is a triangle with error lambda, which is independent of epsilon. When epsilon go to 0, the triangle becomes an impulse with area lambda. The point impulse process is defined as zt is equal to dxt over dt. The xt is a Poisson process. The probability mass is not defined. The mean of zt is equal to lambda, and the autocorrelation T1 T2 equal to lambda square plus lambda multiple delta T1 minus T2. The autocovariance is equal to lambda multiple delta T1 minus T2. The process zt minus lambda has 0 mean, and the autocorrelation is equal to lambda delta T1 T2. That is, the zt minus lambda is a white noise. The fourth process is semi-random telegraph signal xt, which is defined as the number nt1 t2 of the points ti in the interval t1 t2 of length t equal to t2 minus t1 is a Poisson random variable with parameter lambda t. The probability of nt1 t2 equal to k is equal to e to the power of minus lambda t multiple lambda t to the power of k over k factorial. In this part, xt is equal to 1 if k is even. Xt is equal to minus 1 if k is odd. The first order probability mass is equal to e to the minus lambda multiple lambda t multiple e lambda t plus e minus lambda t over 2. The probability of xt equal to minus 1 is e minus lambda t multiple e lambda t minus e minus lambda t over 2. And the mean is e to the power of minus 2 lambda t. The autocorrelation is equal to e minus 2 lambda t1 minus t2, and autocovariance is e to, minus 2 lambda t1 minus t2 minus minus e to the power of e minus 2 lambda t1 plus t2. The probability of xt equal to 1 is not the half, because we start with 1. Probability of xt equal to 1 should be a little higher than the half. The fifth one is random telegraph signal, which is defined as yt equal to axt. Probability of a equal to 1 is equal to probability of 1 equal to minus 1, which is equal to the half, where xt is a semi-random telegraph signal. The first order probability mass is probability of yt equal to 1 is equal to probability of yt equal to minus 1 is equal to the half. The mean of random telegraph signal is 0. the autocorrelation is e to the power of minus 2 lambda t1 minus t2. Autoconvariance is e to the power of minus 2 lambda t1 minus t2. The probability of yt equal to 1 is equal to the probability of yt equal to minus 1, which is equal to the half. This makes us guess that yt may be strict stationary. The expected value of yt is a constant. Also means that the yt is SSS. The sixth one is random walk. If we toss a fair coin n times, k is the number of heads in n tosses. The nt is equal to ks minus n minus k multiple s, which is equal to 2k minus n multiple s. The first order probability method is the probability of xt t equal to xnt is equal to this formula. For nt is smaller than t, t is smaller than n minus n plus 1 multiple t. The mean of this process is 0. The autocorrelation is the minimum value of n and m multiple s squared. The autocovariance is minimum value of n and m multiple s squared. From the probability methods, we guess that when n goes to infinity, we will have Gaussian density. The autocorrelation function contains a term contains the term minimum value of m, which comes from the property of independent increments. The seventh process is Wiener process, which is defined as Wt is equal to the limit of xt when r goes to 0, s squared over t goes to alpha, and n goes to infinity. Xt is the random walk. The first order density function f omega t is equal to this formula. The mean of this process is 0, and the autocorrelation rt1 t2 is equal to minimum value of t1 t2 multiple alpha. The autoconvariance ct1 t2 is equal to minimum value of t1 t2 multiple alpha.